In this lesson, we're going to take a look at the ideal gas law. Now, the ideal gas law is used in order to determine number of moles of a gas given whatever pressure, volume, or temperature conditions we are currently working with for that gas. So it's a very functional gas law that we use quite a bit when we're dealing with a gas. And that ideal gas law, if you've looked at your notes already, the ideal gas law is PV equals nRT. So P obviously is your pressure, and its units are kPa. The volume is going to have units of liter. Moles is going to have obviously unit moles. And your temperature is going to be in the unit Kelvin. So that's what we're dealing with when we're dealing with our units. Now this R is a new one, and if you've looked at the notes, you'll have an idea. But if not, the R is the universal gas constant, and it has a specific value depending on the units that you're using. So when we take a look at our universal gas constant, using units of kilopascals, liters, mole, and Kelvin, our universal gas constant is 8.314 kilopascals times liter divided by mole times Kelvin. Right? So that is your universal gas constant, that number, and that is the unit that it has. So it's really important to use the right universal gas constant depending on the units that you have. So if you are given a question where your pressure is given in ATM or torr, convert it to kPa before using the ideal gas law, because the universal gas constant that we're providing you with is the one that has a pressure unit in kilopascals. There are other ways the universal gas law can be written. The universal gas constant can be written with ATM in its unit or millimeter Hg in its unit, but this is the one that we typically work with. So any of the questions that you're doing, make sure you convert that pressure into kPa if it's not already given. Make sure your temperature is always in Kelvin when working with gas, and make sure your volume is always in liters, and then you're good to go. So we're going to use this to work through a problem here. We're going to try this problem that you see at the bottom of the page, where we have a container that has 125 liters of hydrogen gas. The pressure of the gas is 1.44 atm when the temperature is 35.2 degrees Celsius. And they want us to determine the mass of the hydrogen gas in the container. So if we go back to our ideal gas law, right, this is how we're going to solve the problem. Because we want to find mass, we need moles. And this is our way we can get moles for our gas. And the best thing about the ideal gas law is it works at any conditions that you have for pressure, volume, temperature. It doesn't matter what they are. It's not like using the molar volume that you learned about in a different lesson. The molar volume, that 22.4 liters in a mole of a gas is a mole of a gas. That's only true at STP. Whereas your ideal gas law works at any temperature, pressure, and volume conditions. Okay, so if we take a look, I always suggest that start out by writing down what you have in the question. So we know the volume of the gas is 125 liters. It's already in liters, don't have to convert it. The pressure is 1.44 atm. So this is something that I'm going to have to convert. Now remember, 1.44 atm is the same as taking that 1.44 and we want to do a unit conversion, right? So we're going to multiply by our unit conversion for gases, and we know that 1 atm is the same as 101.3 kPa. That was our unit conversion that we did last week. So once we do the math on that, we can figure out what our pressure is in kPa, because that's the unit that we need, and it would be 145.872 kPa. So we've got our pressure in the right unit now. We go to our next piece of data. That's our temperature, 35.2 degrees Celsius. But we want it in Kelvin, so we have to add 273 to that. So we would get 308.2 Kelvin. We're trying to find moles from our ideal gas law because we want to get a mass, right? And mass we can find if we have moles, okay? because remember, with the molar mass and moles, we can find mass. So we just need the molar mass of the gas, and that we get from our periodic table. It's going to be 2.02 grams per mole. And if you're wondering why that is, remember, hydrogen gas we're dealing with is H2. Its chemical form is H2, so there's 2 hydrogen atoms there, so that's why we have 2.02 as the molar mass. And we're going to need our gas constant of 8.314 kilopascal liters mole Kelvin. So there's all the data that we have. And now we just have to work through the problem. So the first thing we're going to do is find moles. So I'm just going to write down 1, find moles. So we're going to use PV equals nRT. And to get N by itself, because it's multiplied by RT, we can take the RT to the other side and divide, right? If we divide both sides by RT, that will isolate the N value. So we're going to get N equals PV over RT. So N is going to be 145. So now we just punch in our numbers here. The volume was 125 liters. And we're dividing by this quantity. All right, so that's plug in the numbers and then we just do the math. And if you do the math, you will get 7.11605 moles. And if I think about significant digits, everything that I'm working with was 3 significant digits in this problem, except for R, that constant has 4 significant digits. So we're going to take a look at it, and our answer, when we're going to round at the end, we got to think about having 3 significant digits. So I'm just going to underline that so I remember it for later. So we've got moles. The last step then, step 2, is to find the mass. And to find mass, we know that mass is moles times molar mass. So we're just going to take that 7.11605 moles and multiply by 2.02 grams per mole. And we will get 14.3744. And reporting it to 3 significant digits would be 14.4 grams. So that's how we solve that problem. So that's the mass of hydrogen that would be in that 125 liters container. And so we used the ideal gas law to find moles, and then we used our molar mass to convert that to a mass. So that's the beauty of the ideal gas law. It's very functional. You can use it at any pressure, volume, and temperature condition. It does not matter. The key is just to make sure you have the right units with your pressure, volume, and temperature, right? So kPa for pressure, liters for volume, and Kelvin for temperature. If you do that, you should be able to work through it no problem. Any of these type of ideal gas law problems. So good luck with the practice.